Hi, in this course we're going to learn about Stealthwatch basics, what is Stealthwatch system and how do we use it. So let's get started. Now the agenda of the course is to cover the following topics. First, introduce ourselves onto what is Stealthwatch system and what is the purpose of the Stealthwatch system. Then how does it harness the network telemetry? We will explain the word network telemetry in the further slides. How do we classify the data that is being harnessed above? And for the data being classified, how do we use security in it to protect an environment? And lastly, we're going to summarize an entire course. So moving forward to network telemetry. This term is very important to understand before we understand the product called Stealthwatch system. This is the basis of the entire Stealthwatch system that is being designed. Telemetry means an automated communications process by which measurements and other data are collected at remote or inaccessible points and transmitted to receiving equipment for monitoring. In simpler terms, it means that any process that collects the data from multiple other devices, that is called telemetry. In our particular environment, we see a couple of devices such as switches, firewalls like ASAs, access points, routers like ASR, endpoints which has AnyConnect, NV model. All of these devices can behave as telemetry devices. Let's move on to the Stealthwatch. What is Stealthwatch? Stealthwatch is that product which collects those information. That is, a Stealthwatch is a collector and aggregator of those network telemetry for the purpose of security analysis and monitoring. In our figure, we have shown only a couple of devices such as switches and firewalls. But Stealthwatch can accept the data from many devices which are not mentioned. It can also accept data from third-party devices, from cloud, and from many other points. Basically, any device which has the NetFlow capability can send the data to Stealthwatch, and Stealthwatch will be able to accept the data. Those exporters can be anything. The purpose we have a Stealthwatch is that it collects those data, it aggregates the data, perform security analysis on the data and display the results to the user. If there is any problem, attack or any malicious content in the network, Stealthwatch would display it on its dashboard and show that there is a problem to the administrator, and if being configured as Stealthwatch system, it can drop syslog messages or it can drop mails to the administrators or the SIEM administrator. The Stealthwatch system behaves as a complete environment which protects the network. So let's move forward on how does it do that. The motive behind a Stealthwatch is it should know every host in network environment, it should see every conversations, and it should be able to understand what is normal. When we say understand what is normal is that Stealthwatch builds a baseline for all the IPs in the environment. That baseline says that, okay, this kind of traffic for this particular user is normal. This is its day-to-day and every traffic. Whenever any user deviates from that particular baseline, for example, a user is trying to access HTTP servers every day, and suddenly it behaves as an NTP server for all the other environment. That is a deviation from the baseline. When suddenly a deviation from the baseline is there and the deviation is pretty high, then in that case, Stealthwatch generates a notification to the user depending upon the threshold as reached and tells him that, okay, there's a user that is not behaving as it should. So Stealthwatch system understand what is normal for network environment automatically without having any human intervention. If there is any deviation, it alerts the administrators. It can be syslog administrator or a SIEM administrator about the change, and we can respond to the threats as well. Stealthwatch has actions that can respond to the threats appropriately according to which threat or malicious activity has been detected. Stealthwatch doesn't only look at a network environment to get the transactional data, but it also connects with the cloud to understand if what kind of attacks or any new attack is happening, to get the information from the cloud about new attacks or if a certain IP is malicious or if there is a new Trojan that's being detected. It protects the network, the users which are sitting at home, the data center, that is the bread and butter of any networking, and informs all the data if there is any deviation to the administrator. admin see a single screen to understand that if something is wrong in its entire network, just in a single dashboard. So let's get into the components on what are the components of our Stealthwatch. As you see on the screen, the two marks in the red are the core components of a Stealthwatch. These are SMC, that is Stealthwatch Management Console, and FC, the Stealthwatch Flow Collector. Let's start with the components which generates the data, the core components. The first one we'll start with is flow sensor, a Stealthwatch flow sensor. Flow sensor is basically a device that looks at the actual content, actual packets that are flowing through it. It can create a NetFlow. It can create a NetFlow packet which has certain bytes taken from the actual packet. This capability only exists with the flow sensors. It gets those entire information and shares with the flow collector. Once the flow collector gets the data, it can process it. So other NetFlow exporter is endpoint license concentrator. The endpoint license concentrator also looks at the actual traffic that's flowing from the endpoint or to the endpoint, behave as an exporter, create a NetFlow packet, and send it to the flow collector. Third is FR, that is a UDP director. A UDP director is basically one who aggregates the traffic from other flow sensors or any switches, routers, which are any exporter. It aggregates it and sends it to the flow collector. What are the advantage of having a UDP director inside a system is that a UDP director can accept flows on multiple ports. These flows can be syslog flows, this can be your NetFlow flows, it can accept them on multiple ports. And depending upon the configuration of a user, it can send it to the flow collector or a different flow collector. There can be multiple flow collectors. It can choose which one to them depending on the user's configuration and send it to the corresponding flow collectors. This UDP director can exist in high availability. There are two physical models that are available and virtual model as well. In a future lab, we'll be using the virtual model of a UDP directors. After the UDP director, we jump onto the core component called flow collector. Flow collector is the one which aggregates, collects, and stores all the data that's collected from all the NetFlow exporters. It stores and aggregates the data, and this is the heart of a Stealthwatch system. There are 4 physical variants of a flow collector, and there are 3 virtual models that are being available in the market. It collects the data, it builds its own table, it builds events in its own table, and stores them with the flow collector. Now, flow collector is being queried by the Stealthwatch Management Console to get the information for the flow collector, perform analysis, and display the results in the dashboard as seen by the administrator. So Stealthwatch Management Console collects the data from flow collector, and then it connects with other clouds such as cognitive analysis, Stealthwatch cloud, threat intelligence license, or packet analyzers. It connects with all of these clouds, performs processes on that particular data, and display the results. There can be 25 flow collectors that can give the information to the Stealthwatch Management Console. For a system which is having more than one IP that is common to 2 systems, for example, that is very common in scenarios where a company acquires another company. Since the 2 companies, they can have same IPs. In such scenarios, what we need is 2 Stealthwatch domains. That is, it will be having a different flow collector and a different Stealthwatch domain. They can connect to the same Stealthwatch Management Console. Now, each flow collector and the Stealthwatch Management Console should have something called license, which tells us how many flows per second that a flow collector and SMC can accept. There are 2 physical variants of Stealthwatch Management Console available right now and 1 virtual model. It can, as flow collector, it can also exist in high availability. Stealthwatch Management Consoles performs contextual analysis using multiple clouds such as cognitive, Stealthwatch cloud, threat intelligence cloud, and packet analyzers. Now let's see how these data flow through and what happens through the data. So firstly, what we have is For contextual analysis on a Stealthwatch management console data that's been collected, it uses ICE. It can use the intelligence license. It can use global threat analytics. ICE is the one who provides user identity, and it can provide details about which IP is being used by which user. It can provide details about SGT, and it can provide details about the trust sec. Basically, any AAA component that needs to be accessed for a certain IP, ICE can provide those details. Stealthwatch Management Console get those details from these multiple clouds and devices, and gets the data from the flow collector, performs this analysis on the data that's created from the flow collector, and display on the dashboard. The question is, how does flow collector get this data? So there are a lot of exporters here. So these exported telemetry devices, they send the data to the flow collector. It can be encrypted, or it can be a basic NetFlow. This data just need not to be only NetFlow, it can be a syslog traffic as well. Your devices can be any devices which is RFC defined NetFlow device. It can be a Cisco router or a Juniper router. It can be any device which basically runs an RFC defined NetFlow. So for the devices, there are certain devices such as flow sensors in which the traffic flows through them, and the flow sensors have an advantage that they actually look at the traffic that's flowing through them. So what flow sensors do is they are able to capture the traffic, and once they're able to capture the traffic, they put certain bytes of the traffic into the NetFlow itself and send it through. The amount of byte that the NetFlow should be sending to the flow collector is entirely on user defined configuration. By default, it's about 12 bytes, and it depends on which version of NetFlow you're using. That's for 6.9 version. So flow sensors are being deployed on the hypervisors, and these hypervisors can be your VMware hypervisor, or can be KVM, anything. So hence, that's why the flow sensor is able to get the actual traffic that's flowing through. Now, lastly, one of the methods where data can be collected is also through UDP director. So in scenarios where multiple certain devices sends data on a particular port, and since flow collector can only accept data at one single port, and that port can be user defined, so due to this reason, a flow collector may not be able to accept the traffic from all the other devices. That's where the UDP director comes in hand. UDP director collects the data, aggregates the data, and sends it to the flow collector. The difference between UDP director and flow collector is UDP director can only aggregate and send it through, like a relay. But flow collector can aggregates, collects, stores, as well as analyze the data. UDP director is an optional component. If you don't have in the network, your Stealthwatch system can still exist and can still work beautifully. For bigger environment and for bigger deployments, we generally recommend using UDP directors. Now finally, what we have is an endpoint license. What you can have is that the endpoints, such as your machine, which is sitting, your laptops that are sitting in the network, but it can have modules like AnyConnects or NAM. Such modules can also send the data to the flow collector. And finally, for proxy data, we can have a proxy server where whenever a user connects to a network, it gets that forward proxy. It goes to the forward proxy, send the data to the internet. That forward proxy is responsible for sending the data to the flow collector. This way, all the users' IPs that are getting access to internet or anywhere in the world or any other data center are giving the information to the flow collector, and flow collector is able to aggregate them and understand if there is any shadow IT program happening or if there is any attack being happening. So this is how a Stealthwatch system is able to collect the data, and this data is being utilized by the management console using multiple clouds to analyze and perform analysis on this particular data and give the information to the user, informing that whether this is a threat or not. Security packet analyzer is one of them. The beauty of this security packet analyzer is can actually look at the packets which are being flowing through and perform analysis on that particular packet. So other clouds can be a Stealthwatch cloud as well. Now moving on to the core components of a Stealthwatch. So there are two components, the two devices that are necessary for Stealthwatch system to work. First is Stealthwatch Management Console, and second is Flow Collector. Stealthwatch Management Console, as we understood, that it can be a physical appliance or a virtual appliance. That there are two interfaces that are available. Basically, there's a Java interface, there's a web interface. In web interface as well, there are two parts. You can have a web interface or a web administrator interface. You can also access the Stealthwatch Management Console using the CLI. It's basically a Linux-based CLI. In Stealthwatch Management Console, it accepts the data from the flow collector, perform the analysis using multiple clouds, Stealthwatch clouds, ThreadGrid clouds, using IaaS, and gets data from other sources, perform the analysis on those IPs, and display the information. Flow collector, on the other hand, is just to aggregate the data, normalize the NetFlow, and gets as much information as it can from the other environment. So there's one more thing that's needed. Apart from these two devices, we need a flow rate license. So by default, for all the hardware appliances, you'll get 30 days of license, trial license free. And for the virtual appliances, the license need to be bought beforehand. So these licenses tells us what is the flow rate that a flow collector can accept the data. If there's due to any burst that rate exceeds, then a Stealthwatch system will display that there's a burst and the flow rate, much higher flow rate has reached than the licensed. And Stealthwatch system can also generate the alarm if being configured. And if there's a consecutive increase in the flow rate and consecutive from the license that's being purchased, then it is recommended that we should buy a higher flow rate license. Alright. Now, having understood how every component of a Stealthwatch system works, you will understand for the data that's being collected, how do we harness that particular data. Alright, so the first step to this is called network stitching. So there's a term called NetFlow stitching. Whenever a data flows in one direction, we see a flow being created and sent to a flow collector. So the first line shows that a flow is being created when a traffic goes from 10.222 to 10.1111, and another unidirectional flow is being created from 10.1111 to 10.222. So these two datas are basically the flows, and when these two datas are being combined together to form a bidirectional conversation. So this is called network stitching. Network stitching is to take flows and stitch them together to behave as a conversation. And when these conversations are present to the user, it makes far more meaningful information. Now the next topic in the telemetry processing on harnessing this data is called de-duplications. There have been scenarios when a certain flow can take multiple paths to reach its destination. Then in that case, multiple conversations can be created with network stitching. The process where we collate and normalize these flows is called de-duplications. It's a way of saying that when multiple network stitching has occurred also the way, it identifies those duplicate conversations and combines them and tells us which all devices, which all interfaces it has flowed through the network and place them in a single conversation flow. Once we have them in a single conversation flow, this gives a very good idea to the user that who is talking to what and through which all paths it's being followed through. This entire thing that we have seen is called general ledger. Now in this general ledger, what we see is that the traffic traffic has gone from 10.10.18.102 IP to 216.191.247.145 IP. This is called transactional context, where we know all the 7 details: source IP, destination IP, source port, destination port, protocol, interface, that is the input interface, and DSCP. So we know all these values, and we can build a transition record basis on the network stitching as well as de-duplications. It tells us who is trying to access who, on what protocol and port number, and how many packets are being sent through, what is the MAC address of those particular IPs that I've been trying to, when this happened, and more details are mentioned. This entire information just can be done through a Stealthwatch management console, and this is a highly scalable environment since multiple data, multiple flows are being collected to form one conversations. Now, having understood this transactional record on how this has happened, Stealthwatch system can also connect to multiple clouds, as we discussed earlier, such as Stealthwatch cloud or a threat grid cloud or an advanced malware protection cloud, to get the contextual data about the network. Now we will analyze the same flow from the contextual perspective. So this is exactly the same flow, and in this particular flow we'll see that our ICE device is able to give that this particular IP 10.201.3.149 belongs to Ken, the user. So Stealthwatch system polls the ICE using something called PX grid. That's an interface to connect the two devices. It polls the ICE using that PX grid and gets the information that this IP 10.201.3.149 belongs to Ken. Now it checks with the threat grid cloud, sees where is this IP, what is the geographical location of the IP 89.108.67.143, and the threat grid cloud has replied by saying that this IP belongs to Russian Federation, it belongs in Russia. Similarly, the other details such as flow sensor can give us that what is the payload, what is the actual packet that flowed through in this conversation. It can give us a GET request has been sent out for this particular URL. Similarly, all this information can be collected from a contextual cloud, where it gives a very good information. Alright, when two users or two hosts or two IPs are trying to connect to each other, they're talking to each other on what are they talking about, what is their port, what is their protocol, and if there is any change in their baselines, it gives all the information in the contextual plus transactional analysis. Now, this is how we harness the data that's being collected by the flow collector and being done on the Stealthwatch management console. It's time that how do we classify those IPs? For example, we have got an IP 10.201.3.149 and 89.108.67.143. How do we classify that which IP is trusted, which IPs are untrusted, which IP belongs to inside network, which IP belongs to our outside network? So this moves on to the next step called data classification. So there's a concept called host group. In Stealthwatch, each IP is represented by a host. So multiple hosts, when they are clubbed together into a single group, is called host group. There are a lot of predefined host groups mentioned. There are three. One is inside host, another one is outside host, and lastly a certain host group that are being created through threat intelligence, such as command and control center, top of the racks. So on the left hand side on the picture that you notice, that inside host has something called catch-all. Catch-all means for all, it includes all the IPs that includes in a Stealthwatch system. Now we can segregate those IPs on the basis of their function, on the basis of their locations, and again on the basis of the function, what services they are providing. Are they behaving as an NTP server? Are they behaving in NTP servers? So that's how we classify the IPs. The ideology behind creating this host group is because it's being in a Stealthwatch system. Thus your system becomes most valuable when we classify the IPs on the basis of their function. The Stealthwatch system will be far more meaningful if each IP is known to belong to a certain particular predefined group. In a Stealthwatch system, we can create our own host groups, we can delete the existing host groups, we can modify the host groups, we can do any custom things with those host groups. Now this is how we classify our IPs in a Stealthwatch system. Now the last part is, once we have got the data, we have classified the IPs that this user belongs to which particular type, it's time to perform security. What is the security model that the Stealthwatch system uses? So there are three core components in a Stealthwatch system. First one is called security events, second is called indexes, and lastly alarms. So security events are basically by default in 6.9 version there are 97 security events. So whenever a security event gets triggered, it raises the indexes. A security event can raise multiple indexes. For example, in this particular scenario, this security event gets triggered called SQLF. This particular security event adds point to multiple indexes, 3 indexes. First one is concern index, second is target, and third is command and control. So it adds points to these particular indexes. And whenever the index passes a certain tolerance level or threshold level, it generates the alarms. The security events can also generate the alarms directly if they want to. Certain security events have to, but certain security events they can wait. For example, this is a security event of ICMP request. That ICMP, if there's certain 1000 ICMP requests are being sent out, then these many numbers of points get collected. Concern index raises a certain level, and the moment it crosses the level, it generates the appropriate alarm. Now, the question is, what is this concern index, CI? Concern index is like a reputation index. So whenever the concern index is very high, this means the reputation of that particular host is very low. Second is TI, that is a target index. It is exactly opposite of the concern index. Concern index is basically mentioning the source, the one who's generating this all data. Target index is the destination to which this attacks or these points are being registered on. It's being focused on. So in simple terms, once your security events get triggered, it can generate the alarm or it can raise indexes. Once the indexes cross a certain threshold, they raise the alarms in turn. And that is how a Stealthwatch system is able to know that something bad is happening. These alarms can be sent as a notification in a syslog message or as a mail to the administrators, and they can get to know that this particular IP is malicious or is doing something wrong. So this is how your Stealthwatch performs security on your entire network. So just to summarize, what we have learned so far is a Stealthwatch system is a system which uses the data that is flowing through the existing network, analyze the data with the help of multiple clouds and devices, and performs security analysis and inform the administrators or take actions on the basis of that particular data. Thank you.